Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Afiqah binti Amran. My metro number is 2015218 and I will talk about thin layer chromatography. TLC is a simple, quick and inexpensive procedure that gives the chemist a quick answer to how many components are in a mixture. Thin layer chromatography is one method for testing the purity of compounds and identifying substances by which mixtures are separated into their individual components. In TLC, substances are distributed between a stationary phase and a mobile phase. The mobile phase is generally a mixture of non-polar organic solvent, while the stationary phase is polar inorganic solvent, which trap between the cellulose fibers of the TLC plate. One phase is the solvent held in the pores of the plate used, and the other is the mobile phase, which moves over the plate. Components of the sample will separate readily according to how strongly they absorb onto the stationary phase versus how readily they dissolve in the mobile phase. To get the process started, the mixture is dissolved in the fluid called the mobile phase, which carries it through a system called a stationary phase. The nature of the specific mobile and stationary phase determines which substances travel more quickly or slowly, and that is how they got separate from one another. These different travel times are termed as retention time or RF. The different constituents of the mixture have different affinities for the stationary phase. The different molecules stay longer or shorter on the stationary phase depending on their interaction with its surface sites. The separation is based on the differential partitioning between the mobile and the stationary phase. Firstly, we prepare a few pieces of tissue papers and draw a straight line on it. This straight line is because we're gonna spot the marker onto the straight line. Okay, so for this experiment, I'm gonna use the highlighter, green color highlighter and maroon colored Sharpie. Okay, so a few color pigments mixture are placed on the tissue paper and the container is filled with water. The tissue paper, the support, is gonna attach with another support to prevent it from submerged completely into the water. So depending on their polarity, it dissolves the molecules present in the mixture as the solvent rises up the paper. The solvent continues to rise up the tissue paper. Molecule of each pigment leave the solution at different places because of different polarity. Hence, every pigment rises in a particular level on the chromatograph on the paper and gets separated in the process. So this is the blue one is separated from the yellow one. So next is the Sharpie one. So because water is polar, because of the difference in electronegativity between hydrogen and oxygen, capillary action is greater in water due to its high polarity. Sharpie is non-polar pigments. So a chemical that is very non-polar will not dissolve at all in a very polar solvent. Because of that, the Sharpie cannot dissolve in water that is polar. Okay. So when the solvent has finished moving up the paper strip, we can remove the paper from the cup and immediately mark with pencil the highest point the solvent travel up the paper strip, and the RF is measured in millimeters from the original color dot to the highest point, to the middle point of the first color pigment, travel up the strip, which is yellow. So for the blue one, the middle is 1.6 cm and for the total solvent is 4 cm. For the yellow one, the middle is 3.5 centimeter. And for the water is 4 centimeter. The sample is pigments of an ink that are insoluble and applied not as solutions but as finely ground solid particles mixed with a liquid. In general, the same pigments are employed in oil and water-based paints, printing inks, and plastics. Pigments may be organic or inorganic. The support is tissue paper. They help retain the stationary phase distributed as a thin film to accelerate the achievement of the equilibrium state between the aqueous and organic pieces. An ideal support must meet many requirements, such as to display good wettability by the stationary phase and to retain it in sufficient amounts. The fixed phase must not tear off the support while with the flow of the mobile phase. The solvent or solvent mixture used in this experiment is water and is synonymous with mobile phase, that is a developing solution that travels up the stationary phase due to capillary action carrying the samples with it. We will find that as you increase the polarity of the solvent system, all the components of the mixture move faster and vice versa with lowering the polarity. Polar solvents dissolve polar compounds more effectively than non-polar solvents and vice versa. The ideal solvent system is simply the system that gives the best separation. The retention factor RF may be defined as the ratio of the distance traveled by the solute to the distance traveled by the solvent. It is used in chromatography to quantify the amount of retardation of a sample in a stationary phase relative to a mobile phase. RF values depends on temperature and solvent used in the experiment. So several solvents offer several RF values for the same mixture of compound. The larger an RF of a compound, the larger the distance it travels on the TLC plate. When comparing two different compounds run under identical chromatography condition, the compound with the larger RF is less polar because it interacts less strongly with the polar adsorbent on the tissue paper. So the RF for the blue is 0.4 and for the yellow is 0.86. Of blue, sorry.